Hi, we are Team SSH.exe presenting AgentLab for AI tooling track at ASU Claude Builder Hackathon. Problem is, AI agents are being shipped like production software, but tested like guesswork. Prompt changes, tool changes, models change, and suddenly your agents behave differently, but you have no way to prove why. We have CI/CD for code, we have version control for systems, but for AI agents, there is no version control for behavior, no structured way to track reasoning changes over time, roll back a broken prompt or tool chain, or inspect what actually changed between two versions. So we've built AgentLab, a CI plus evaluation layer for AI agents with behavioral version control at its core. Version your agent, roll it back, and diff behavior across runs, not just code. Because the real question isn't what changed in your code, it's what changed in your agent's behavior. AgentLab is for AI engineers building agent workflows, teams deploying AI systems, and anyone who needs deterministic insight into non-deterministic systems.
Welcome to AgentLab. I am Vera, your agent evaluation and versioning guide. I will help you track how your agent behaves, evolves, and improves over time. AgentLab gives you a structured way to work with agents beyond just running them. You can define task suites, compare executions, and analyze how your agent responds across different conditions. Every change you make is preserved so you can revisit and compare different stages of your agent. But this makes more sense with a real example. Let's help Hetavi, a new user, get started. Hetavi has already built an agent, 02 Enterprise SQL. What she lacks is visibility. She can run it, but she can't systematically understand how it changed. Hetavi begins by cloning the AgentLab repository and setting up her environment. She installs dependencies as defined in our setup guide. Next, Hetavi creates a .env file. This is where she adds her API keys, for example, LLM provider keys and Langfuse cloud credentials for observability, so no local setup is required. This ensures every execution is properly traced and stored. Evaluate her agent. As the agent executes, I capture each step of the interaction pipeline. Hetavi should start her dashboard locally. Here is Hetavi's dashboard. Let's go to the version history. Here are all Hetavi's executions. Each one captures a complete snapshot of how her agent responded at that point in time. These trace logs show the actual execution path taken by the agent. So Hetavi is not limited to seeing the final answer. She can inspect the sequence of steps, tool calls, and internal flow that produced it. That makes debugging much more concrete. If something breaks, she can trace where the run diverged instead of guessing from the output alone. But what really matters is what she does next. This is also where the human feedback loop comes in. Hetavi can review a run, decide what worked, identify what felt weak, and use that feedback to refine her agent. Maybe the reasoning is too shallow, maybe a tool was invoked at the wrong time, maybe the system prompt needs tightening. Based on these observations, she will be prompted suggestions to refine prompts, tool usage, or decision logic. Then she runs the agent again and compares the new version against the previous one. So every version becomes a part of the structured improvement cycle. Review, adjust, rerun, and validate. Diff viewer. This is where AgentLab becomes more especially powerful. Instead of diffing only code, we can diff the working parts of the agent itself across runs. Here, Hetavi can compare trace logs, code revisions, system prompts, and execution outcomes side by side. She can see exactly what changed between her two versions, not just that the result looks different, but which underlying pieces changed with it. For example, if two runs produce different answers, Hetavi can check, did the trace path change? Did the system prompt change? Did the implementation in the agent code change? Or did the execution improve without any regression elsewhere? That gives her a much clearer explanation of cause and effect. AgentLab also generates diff summaries inside the UI, which helps Hetavi move faster from diagnosis to iterations. If the newer version is worse, Hetavi does not need to reconstruct anything manually. She can roll back to a known good state and continue working from there. That makes experimentation safer because every change is recoverable. For more advanced setup and customizations, detailed documentation is available on the UI.
Thanks, Veera. As agents become more capable, the risk is not just failure, it's failure without visibility. If an agent starts behaving unexpectedly, teams need to know what changed, why it changed, and how to respond quickly. AgentLab is designed around that responsibility. Instead of replacing human judgment, it keeps humans in the loop by preserving execution history, exposing trace logs, surfacing diffs across prompts, code, and runs, and allowing rollback to a known good state. That matters because the people who can be harmed by unreliable agents are very real. Developers shipping broken changes, product teams making decisions on misleading outputs, and end users interacting with systems that may drift silently over time. Our approach is to make agents more governable, not by hiding complexity, but by making changes observable, reviewable, and reversible. The next step for AgentLab is expanding from single agent workflows to multi-agent systems. As orchestration becomes more common, teams will need visibility not just into one agent's execution, but into how multiple agents coordinate, hand off tasks, and fail across shared workflows. We also plan to launch AgentLab as a proper Python package, so teams can install it directly into their development environments and integrate it more naturally into existing agent pipelines. And finally, we want to extend Veera from being a guide inside the platform to becoming an active interface for it. That means developers could give natural language instructions like Vera, run an eval on the latest version, compare this run with the previous one, or roll back to the latest stable state, and Vera would execute the corresponding CLI actions directly. That would make agent evaluation and control even more accessible, especially for fast-moving teams. To conclude, AgentLab is our answer to a simple but urgent gap in AI tooling. We already have strong discipline for shipping software, now we need the same discipline for shipping agents. With AgentLab, teams can version agent evaluation, inspect traces, compare changes, incorporate human feedback, and recover safely when something breaks. So instead of asking, does this feel better, we can finally ask, what changed, what improved, and can we trust it? That is the shift AgentLab enables. Thank you.